Hello dear students, how are you all? In this video, I'm going to discuss about the projectile motion on inclined plane. So in this we have two types. One is down to top projectile and the inclined plane and top to down projectile in inclined plane. So in this video we'll discuss about down to top projectile. Okay, wherein I'm going to derive the expression for the time of flight and then range of the projectile, also the maximum height reached by the projectile from the inclined plane. Okay, so we'll discuss one by one. So here we have the projectile which is projected at an angle theta with the inclined plane. Already the inclined plane is having an angle of inclination, that is alpha. So with that, if it is thrown at velocity u or with velocity u, the trajectory is shown like this. The trajectory of projectile is like this. So what I will do is, I will consider along the inclined surface, I will consider x-axis, and exactly perpendicular to it, I am going to consider y-axis as shown in the diagram. Hope it is clear to you. Now, from the point of projection to this point, where the projectile is going to hit the inclined surface, so what is the horizontal distance, or what is along x-axis, what is the distance traveled? That is given by range of the projectile, and perpendicular to it along y-axis, what is the height reached, maximum height reached, that is called h. And what is the time taken to reach from this point of projection to the end point? To derive that, I am going to resolve the velocity and acceleration components along x-axis as well as y-axis. Let us take the velocity along x-axis as u cos theta and velocity along y-axis is u sin theta. Clear? So you can write the same diagram as I have given in the right side also. So u cos theta, u sin theta. Then what about g? G here always acts downwards, acceleration due to gravity. So perpendicular to it, we have minus g cos theta because it is in the opposite direction of y-axis, that is towards negative y-axis. The component of g along negative y-axis is minus g cos alpha, that I have written here, minus g cos alpha. And acceleration due to gravity along negative x-axis is minus g sin alpha, that I have written here. So the same diagram without considering the inclined plane as a reference, we can write like this. So I have just tilted it to the horizontal direction, that is along x-axis and y-axis generally, and just written what is the velocity components and acceleration due to gravity components. Okay, by using this data, I'm going to derive the expression for first, that is time of flight. What is the time taken for the complete projectile? For that, I'm going to use the kinematic equation of motion, that is S is equal to ut plus half at square along y-axis. So time of flight, right? Yeah. So for the complete projectile, if you take from here to here, what is the displacement along y-axis? It is 0. So for complete projectile motion, the displacement along y-axis is 0. Correct now? Because it is moving along x-axis. It is moving along x-axis. Y-axis component or the value of displacement along y-axis from initial point to final point will be 0. Only x-axis value will be there. Y-axis value will not be there. Now if I consider, so what will be the initial velocity along y-axis? That is u cos theta into t is the time of flight. Let me write it as capital T, plus half into acceleration along y-axis is minus g cos alpha. Correct, no? That is given in the previous slide. So acceleration along y-axis. Now, what is t square? It is the time of flight whole square. Let us take this part to the left side. You will get g cos alpha t square divided by 2, that is equal to u cos theta into t. So here 1t will get cancelled, and then if you solve for t, you will get u cos theta divided by, we have 2 also here, into 2 divided by g cos alpha. This can also be written as 2 into initial velocity along y-axis divided by acceleration along y-axis due to gravity. So this is the expression for time of flight. Clear? Yes. Next, move on to maximum height reached. So what is the maximum height reached? H. So at the maximum height, the velocity along y-axis will be 0. We will have to consider only maximum velocity along x-axis, which is nothing but u cos theta. U cos theta, because along x-axis the velocity is not changing. Sorry, it is changing with respect to theta, right? Yeah, it is fixed. U cos theta and g is there. Yeah, it will change. So at maximum height, its velocity is u cos theta and we have to consider acceleration due to gravity. Let me erase this. You cannot directly take this here. Just a minute. Okay. Now the velocity along y-axis is 0 and velocity along x-axis is vx. I'm going to substitute these values here. So velocity along y-axis will be 0, initial velocity square, that is equal to initial velocity along y-axis is u sine theta whole square plus 2 into okay, I should go back then to erase this. Okay. 2 into acceleration along y-axis is minus g cos alpha into total displacement along y-axis is h. Therefore, we can take this right side, left side. So 2g cos alpha into h is equal to u square sine square theta. So h is equal to u square sine square theta divided by 2g cos alpha. So this is the expression for maximum height reached by the projectile. Okay, that is this. Next, this can also be written like this. H is equal to initial velocity along y-axis square divided by just 2 acceleration along y-axis. Even though, yeah, that is this. We have minus a here, we can take the magnitude. Okay. Next, what about the range of the projectile? This will be lengthier. So in JEE or NEET examination, you can directly use this formula instead of the final formula that I'm going to derive here. That is, displacement along x-axis is range. You can write it as r. What is the initial velocity along x-axis? That is u cos theta. Yes, u cos theta into time of flight we have just derived, that is 2u cos theta divided by g cos alpha. 2u sin theta sin alpha, sorry, it is theta only, not alpha. Arey yaar, I need to go back every time to erase this, divided by you can take what is the value of g cos alpha. Hope I have written the same thing previously. Yeah, so then half into acceleration along x-axis is minus g acceleration x-axis minus g sin alpha into t square, that is 2u sin theta divided by g cos alpha whole square. So we just have to simplify this. So finally you will get, I will give the direct formula, that is 2u square sin alpha divided by g cos square alpha, sorry, this is theta, into cos theta plus alpha. So this is the formula. If you simplify this, you will get by taking the common terms 2u square sin theta and all. If you take common, you will get cos theta into cos alpha plus sin theta into sin alpha. Minus is there, minus sin theta into sin alpha. So from that you will get this formula. So this is about this. What is this? The projectile motion on inclined plane. We'll discuss about the projectile motion on inclined plane from top to down in the next video. Till then, take care. Bye bye. Thank you so much.